Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be modeling exponential functions with tables and graphs. Before we do, I just want to review a definition for exponential functions that we learned in our previous lesson. So exponential functions are defined by an equation of the form f of x equals a times b to the x power, where a cannot equal 0, b must be greater than 0, and b cannot equal 1. Now, in our previous lesson, we learned that if your base of your function is greater than 1, then the function will increase from left to right. And if the base is between 0 and 1, the function will decrease from left to right, or decay. Okay, so in example 1, it says some values for the function f of x equals 4 times 2 to the x power are shown in the table below. Identify the values of a and b and tell if the function represents a growth or decay. So in this problem, our a value is 4, our base of our function is 2, and because b is greater than 1, this function will grow. All right, problem B. Describe any patterns you see in the table and use the pattern to find the missing values. So they've shown us 3 values on this function, 0, 4, 1, 8, 2, 16. So our x values are increasing by 1. Let's see what's happening to the y values, or the function values. So we have 4, 8, 16. So notice that each y value is being multiplied by 2. So I'm going to say as x increases by 1, y is increasing by a factor of, or BFO, 2. In other words, each y value is being multiplied by 2. So 4 times 2 is 8, 8 times 2 is 16. Now knowing that allows us to get the value of y when x is 3. So 16 times 2 is 32. Now we could go backwards. Instead of multiplying by 2, we could divide by 2 to get the y values above this. So 4 divided by 2 would have to be 2. 2 divided by 2 would have to be 1. So once you know the factor that the y values are increasing or decreasing by, it's easy to fill in any missing y values. All right. Problem C. In an exponential function of the form f of x equals a times b to the x power, a represents the initial value. In the function f of x equals 4 times 2 to the x power, which value is the initial value, and what point on the graph does this value correspond to? So in this problem, a was equal to 4. That means the initial value of the function is equal to 4. And this value corresponds to our y-intercept. All right, problem D. In an exponential function of the form f of x equals a times b to the x power, b represents the growth factor. In the function f of x equals 4 times 2 to the x, what is the value of b, and how does this affect the y values? Well, we've basically already answered this question, because we said that the b, or the base, is 2, and it wants to know how does this affect the y values and the shape of the graph. So the y values are being multiplied by 2. So the function increases from left to right. The y values are all being multiplied by 2, so the function increases from left to right. All right, example 2. Some values for the function f of x equals 64 times 1/2 to the x power are shown in the table below. Identify the values of a and b and tell if the function represents a growth or decay. So here our a value is 64. Our b value, or our base of this function, is 1/2. Now, because this base is between 0 and 1, we know this function is going to decay or decrease from left to right. All right, so let's try to fill in our missing values from our table. So they gave us 3 values, 132, 216, 3,8. So in B it says describe any patterns you see in the table and use the pattern to find the missing values. So as x increases by 1, y decreases by a factor of 1/2. So 32 times 1/2 is 16, 16 times 1/2 is 8, and so on. Now, to fill in the missing values, instead of dividing by 2, we're going to have to multiply by 2. So this would have to be a 64. This would have to be a 128. And this would have to be 256. So in the exponential function of the form f of x equals a times b to the x, a represents the initial value. In the function f of x equals 64 times 1/2 to the x, what is the initial value? So our initial value in this problem is 64. And you can see from the table, 64 is indeed our y-intercept. D, in an exponential function of the form f of x equals a times b to the x power, b represents the growth factor. In the function 64 times 1/2 to the x power, what is the value of b, and how does it affect the y values of the function and the shape of the graph? So in this problem, the value of b was equal to 1/2. So the y values are being multiplied by 1/2, and the function decreases from left to right. Now, in our first 2 examples, we represented an exponential function using tables. We can also represent exponential functions using graphs. So let's look at the steps to graph an exponential function. The first thing you want to do is determine whether the function is increasing or decreasing. To do that, you will look at the b, the base, all right? The next thing you'll do is determine the initial value, or the y-intercept. And the last thing is you'll use the growth factor to help you determine a couple of additional points on either side of the initial value, and then sketch. So in problem A, we have f of x equals 5 times 2 to the x power. So we know our a is 5 and our base is 2. Now we want to determine, is the function increasing or decreasing? So we look at the b. The b is greater than 1, so it's increasing by a factor of 2. Now the initial value of this function is 5. So that helps us fill in our table. I know my y-intercept must be 5. So I'm going to go ahead and plot that on the graph. I have a y-intercept of positive 5. All right. Now, to get additional points, I could increase my x by 1, and the y values would increase by a factor of 2. So 5 times 2 would give me 10. So 110 would be about right there. Now, for my x, let's go up by 1 again. So when x goes up by 1, the y values multiply by a factor of 2. So this would be 20. So 220 would be like up here. All right. Now, what about on the other side of the initial value? What about if x is negative 1? So instead of multiplying by 2, I would have to divide by 2. So 5 divided by 2 gives me 2.5. So negative 1, 2.5 would be about right there. If I want to see what happens at negative 2, I could divide by 2 again, and that would be 1.25. So and that would be like right here. All right. So now we can see that it is curving around something like this. Just a rough sketch. Okay. Now, once you have the basic shape of your graph, that allows you to get the domain and the range. Now, for the domain, it goes forever to infinity, negative infinity to the left, positive infinity to the right. So the domain must be all real numbers. Now, the range, it never goes below the y-axis. It stays in the positives. So the y values, because they stay in the positives, they must all be greater than 0. All right. Problem B. Graph f of x equals 9 times 1/3 to the x power. So remember, the first thing you want to do is identify your a value, which is 9, and your base of your function, which is 1/3. Then you want to decide, is the function increasing or decreasing? Well, in this function, our base is between 0 and 1, so it's decreasing by a factor of 1/3. Our initial value is 9, which allows us to fill in the initial value on our table, 0, 9. Now, because I'm multiplying each y value by 1/3, if I increase x by 1, this would have to be 3. If I increase by 1 again, 3 times 1/3 is 1. So each time, divide by 3, divide by 3. So to get negative 1, I'm going to have to go the opposite way and multiply by 3, which means this y value is 27. So let's plot this. Negative 127 would be about right here. 0, 9 would end up being right here. Let's see, 1, 3 would be like right here, and 2, 1 would be like right here. So you can see this function is decreasing from left to right. So for the domain, it goes to negative infinity on the left and positive infinity on the right. So that's all real numbers. On the range, the y values are all staying in the positive numbers. So the y must be greater than 0. All the y values are staying in the positives. All right, problem C. Graph the function f of x equals 4 to the x power. Now, in this problem, it's kind of hard to see what the a value is because this is an understood 1. So this should be 1. Our base of the function is 4. Then you decide, is it increasing or decreasing? Well, because the base is 4, I know my y values are going to be increasing by a factor of 4. So when I fill in my table, I always start with your initial value, 0, 1. Then you can fill in to the right of that point. So if I'm increasing by a factor of 4, 1 times 4 is 4. 4 times 4 is 16. Now, to go the other way, I'm going to have to divide by 4. So this would be 1 divided by 4 is 1/4, or 0.25. 0.25 divided by 4 is 0.0625. So that's a really small number. So when I plot this, -2.0, that would just be barely above the x-axis. Then -1.25 would be just above that. 0, 1 be right here. 1, 4 right here. 216 way up here. So this function looks something like that. Oh, we never filled in our initial value, excuse me. Now, if you wanted to, it doesn't ask you to, but if I wanted to do the domain, it would be all real numbers again, range. It's staying in the positive, so y would be greater than 0. All right, and that concludes today's lesson, modeling exponential functions using tables and graphs.